इसमें मतलब अगर आप वो हटा दोगे तो क्योंकि मेन मोटिवेशन इज दैट आफ्टर एमएस लाइक पीपल कम नॉट टू डू एमएस पीपल कम हियर टू डू जॉब वाया एमएस
नहीं वो पर एमएस के लिए तो अलग से कोटा है ना.
सर कितना ही है
20,000.
20,000
हाँ, so it's like one third of the whole H1B quota is for us, right?
तो
Yeah, yeah.
मतलब आई थिंक अभी तक होता था क्योंकि नंबर ऑफ एप्लीकेंट इंडिया से ज्यादा होते थे तो प्रोबेबिलिटी ज्यादा होता था सिलेक्शन का जब बस सैलरी बेस्ड हो जाएगा तो बाकी कंट्रीज वालों को भी थोड़ा मौका मिलना स्टार्ट हो जाएगा
Hmm.
तीस और स्पेशली इंडियन सर्विस बेस्ड फॉर्म हो तो मतलब मोस्टली आउट हो जाएंगी TCS कॉग्निजेंट एंड ऑल द प्रीटी मच
Yeah. So before we start today's session, I just wanted to check. Everyone is still interested in this book, right? Yeah.
At least for me it's good like pretty much because it relates to what I do so
Okay.
but हाँ बाकी लोगों के लिए भी मतलब आई थिंक रिलेवेंट होना चाहिए
Going into details for something, like for example, a supervised fine tuning and data preparation, like they're going into little more detail that I think are not applicable to everyone. But it doesn't harm to learn all these concepts, right? So I'm up for it. But um, like, if people feel that no, this is going too deep, maybe we can pick some other topic. But let's go with this.
I think the idea is to that people become familiar with the concept uh,
Hmm.
and then if anyone wants to do a deep reading they can do on their own
Yeah. All right. So let's get started.
okay okay I will start sharing my screen is my screen visible and please let me know if zoom level is
You
in
can
on
zoom in a little bit. That will help older people here. Yeah,
is this following
that is good.
okay. So we are starting on chapter 4 where our idea is to build personal assistant chatbot. Okay. So even though they are calling it personal assistant chatbot, you can assume this chapter is about building another chat GPT. If you follow these steps, very well, you are kind of building a chat app which will perform all the functions pretty much similar to chat GPT apart from the multimodal capability. What I mean by multimodal capability, keep image processing, a video, that won't be there, but otherwise it will what we are going to build today is it will whatever question you ask it will answer similar to chat. Okay, so first thing before we start on it, right, question, right? Okay, so just if you are designing chat GPT, right, what kind of questions you are going to ask, right? Very important thing, right? What languages should ChatGPT support, right? English, right? Okay. Then, do we need to ensure that chatbot generates unbiased and safe outputs, right? It says basically it can be yes or no, but here it is yes. So it means you need to put guardrails, right? After building the model. Uh, okay. Then what are the tasks that chatbot is expected to perform? So it should be able to provide tasks like information and answering question. Okay. So there can be two kind of thing, right? When you talk to a chat GPT, it's One thing is you are into a QA mode, right? Correct. And then another thing is like you ask just simple information like what's the capital of Paris, capital of France. It says Paris, so you are done. Okay. Now, why I'm saying why it is important is it is important because your training data should be consist of those examples, right? If it's only about providing information and it's not about answering question, we can focus on a training data which it more around the providing information. But if you expect it to do even question answering, you should also have a question answer related. Question one, this is the answer. There's a follow up question, this is the answer. On the top, there's a follow up question, this is the answer. And also, because there are going to be follow up question, you need to have a something in the memory management. GPT should be able to remember and the context basically. It should be able to remember the context in which it is getting asked question. Okay. Then non-text modalities like should it have multimodal capabilities, so image, audio, or video. So we are going to work only on sorry, uh, video. And then how long should the chatbot maintain the conversation context, right? Okay, so it's saying we can have a context window of almost 4096 token, which is a very good length. Just say if you consider one token as one word and one page usually consists like around 200 words. So you can say that you have a context length of almost 200 pages, like which is almost a small book, right? Okay. Okay. So a chatbot expected to be able to browse website, call external API, or search online. Basically, are you going to provide it with tools, right? So no, let's not focus. So we are not going to focus on the tool. This is just thing what you call like something say agentic AI, right? Which has become very famous. So it's like what happens in agent. You define an agent. An agent has capability to reason what the next step should be performed, right? So just say for example, Chat GPT, you can say it's also almost works like a agent. Just say if you ask a mathematical question, it is going to call a calculator. It is not going to compute it itself. Okay. Or if you ask it to browse from the website, it has a tool which helps it browse. Okay. It can connect with a database also. So to the GPT. So here we are not building this. I'm just trying to give a context that what it means by when you connect with this. Okay. So, okay, one more point, right? When I'm talking about tools, right? So you might have heard about MCP, right? So MCP is just a protocol which helps, connecting you to agent with a tool. Okay, you are using a because it's standardized how the communication should happen. So you won't have to write the same snippet of code again and again for each and every tool. You have a standard code which can you can standardize how the input format, how the output format should be, and you can just use same code block for each and every tool and agent communication. Okay. Uh, कोई personalize its interaction with user. Let's not focus on personalization and then instruction based training data. Right? The part I was talking about earlier that you should have a data set like they have a data set of TK examples and instructions and answers. So because this is what this is the most important part, but this is something which you are going to use in the what you say fine tuning, right? Okay, because okay, there are two things, right? When you are again coming from the previous chapter, right? When you are building this chat app, first important step is understanding the language. Second step is able to answer something. Third step is able to answer something as per the human preference. Okay. Okay. Yeah. So yeah, as Manu sir mentioned, right? So uh, depending upon like tokenizer, obviously, like which tokenizer you are using, but in general, you can assume like these many tokens because one word can be split into multiple tokens. So 4096 token would be on average like 3000 words. So yeah, 10 page of text. Yeah,
Yeah, I
thank
didn't
you.
want to interrupt. This was not really important, so that's why I just put in
Yeah.
the chat. Mhm.
But yeah, this gives a good context to people to understand how much exactly the token is in terms of when we, if I say that context length is 28,000 token, so people should be able to relate that way that okay, 28,000 token means around 20. So in GPT, if I remember it right, when GPT-2 was launched, no, 3.5 has a context length of 32K. Okay, and GPT 4.5 has a context length of almost 128K, right? So as we are advancing over period of time, we are able to put more context, which makes model more powerful. Okay. Specifying the system input and output. So basically, this is a very simple problem statement, right? That you need to input a text prompt and you need to get some relevant output. Okay, this is simple. Inter. Yes, ma'am. Sure.
Yeah, so there's one question that was not answered or not asked was memory, user memory. So it just remotely said that no personalization, but I think this was more related to whether user memory will be needed or not.
Right, ma'am. But yeah, memory will be anyway needed, ma'am, because you are going to have a context window, right? You will have a short-term memory cache, might not long-term. When you say personalization, it usually relate to long-term memory. That just say you are logged in into GPT with your account, right? It
Yes, yes,
remembers all your previous conversation. It remembers your information you have provided over a period of time. So it remember what kind of answer you prefer depending upon the thumbs up or thumb down you have given. So it's a more of a long-term memory when you go with personalization. And when you go with a context window only, it's a short-term memory for that. Because it's a just say session-based memory. You
yeah,
launch a session, you get some output, it will remember the context for that particular session. Once you close that session, it won't remember anything again.
yes, yes, sure.
Uh,
So is this context actually maintained by the client or by the server? And like
But context is maintained by the server.
by the server, even though it's not like personalization is not needed, and that context doesn't need to be person.
It is maintained on the server.
Okay.
So, as per this clarifying requirement set, this top question which is shown right now on this screen is that user has asked explicitly that how that conversation context is to be maintained. So the scope here defined is to it is going to maintain the context in the same conversation session. Session means user is going to log in, and in that specific window, all the question answer it is going to keep the status of the previous question answers also. So either that can be maintained in every call that the user is going to give to the server, or server will maintain or store it at the level of conversation, not across the conversation. So this 4096 tokens, I think this is a limit to for the conversation only, for a one conversation. So it is
and
not some.
Yes,
uh,
exactly. I think
Hmm,
so.
hmm.
So when we
So
say one
no, yes.
conversation, sir, it can be like multiple question answer within a
यस राइट
conversation.
राइट
Yeah.
राइट
Okay.
राइट राइट
Okay.
राइट हाँ या इसका ये मतलब नहीं है कि मैं एक क्वेश्चन जो है 3000 टोकन्स मतलब 3000 वर्ड्स का दे दूं बना के, क्योंकि उसके पहले प्रीवियस का भी क्वेश्चन आंसर्स होंगे ना, वो भी तो कुछ मेमोरी लेगा, द टोकन कंज्यूम करेगा ना। तो
And
इसलिए अगर आपने देखा हो कि कभी कभी हम लोग चैट जीपीटी यूज करते हैं तो बोलता है कि आपका ये सेशन खत्म हो गया है, आप नेक्स्ट सेशन खोलो, क्योंकि आपका उस सेशन का जो टोकन्स अवेलेबल होते हैं वो कंज्यूम मतलब हो चुके होते हैं आपके उस वाले सेशन में, कि
mhm.
अब आप और क्वेश्चन नहीं पूछ सकते।
Sir, like uh,
ओके।
okay. Uh, and Manu sir ने अभी कौन बोला from a software engineering perspective we can ask question about scale, latency, like availability requirement, time. So मतलब memory side, like I think I would love to know more, maybe Manoj sir or someone like who has a more background on the software engineering side, how memory management works, right? So maybe not today, or जब भी time अगर maybe end of session अगर time मिलेगा तो we can probably delve deeper into that because I don't have much background into memory management or okay. ठीक है तो next thing is simple, right? This you have an input and output. I will move on to the next page. Choosing a suitable MML approach. So if you remember previous session, right? We were thinking about what kind of architecture we need for that translation system, right? And we went into detail of the three kind of architecture which are kind of available right now. It's encoder only, decoder only, and encoder decoder, right? So we know that encoder only is more like a good listener, encoder decoder is more like a very literal translator, and decoder only is a more of a storyteller, right? So in this case, where you want to have a conversation, a storyteller is what you need, right? Which understand what you are asking and explains you well back. Okay, so we are going with decoder only uh, architecture here. So yeah. Now next important step here is data preparation, right? So sorry, 1 minute. Let me just. This is too zoomed in, so for a bit for me it's a bit hard to scroll. So yeah. Okay. So ठीक है. So data preparation is simply I won't delve deeper because सबको पता है कि it's more like getting data from the web, cleaning up all the non-relevant part, ensuring data is relevant, ensuring it's a quality data, right? So उसमें जैसे important thing is you identify what the language it is, content quality filtering. You also want to ensure that it's a readable, it's not a spam. It's a heuristic checks like context length and text structure. Right? So you don't want low quality text in your model. Okay. So uh, other thing like we can use other classical ML models probably or another smaller AI model to remove inappropriate content and anonymize sensitive information, low quality data, duplicated data, irrelevant and tokenized text. Right? Okay. So after doing all this, basically getting the data and cleaning up, we are going to tokenize it using byte pair encoding. Uh, so last chapter, may I we were discussing byte pair encoding, right? So I did a bit of reading there. So byte pair encoding is so it's like splitting word into multiple सब वर्ड. ठीक है, तो जैसे एक एग्जांपल था अनबिलीवेबिलिटी. ठीक है, so what it will do is it's trying to make a logical break. Un will become a word, believe will become a word, and ability will become a word now, and it will also remember how these each of them are related to each other. तो इससे क्या होता है कि इट इज वन थिंग इज कॉर्पस ऑफ वर्ड बहुत बड़ा नहीं होता. इफ यू ट्रीट ईच वर्ड एज अ वन व्हाट यू से टोकन, इट विल बिकम अ वेरी बिग एम्बेडिंग. बट यहाँ पे बाइट पेयर इनकोडिंग में क्या होता है कि मे बी आई कैन शो एन एग्जांपल. ओके, आई हैव इट ओपन इन चैट जीपीटी. सो ओके, ओके, ठीक है. तो ठीक है, so basically that's right. It is going to split into unbelievability. So इससे क्या होता है कि because AB will be come, AB will come. Oh, sorry, I'm not looking at the screen one. Okay मैम, अच्छा मैंने कभी ट्राई नहीं किया. आई विल ट्राई दैट. Okay. But yeah, just to continue the conversation, or you want to explain this, ma'am? You want to take this up? Okay, all right. Okay. So, ठीक है. So, if you see, right, it's a very logical sequence. Okay. this or this, because un will come multiple time in across the dictionary. Believe will come multiple time across the dictionary. So it's about breaking into most logical word which will come multiple times. Just it's a very rare word. Rare word मतलब जो बहुत out of bag kind of. जैसे if I say word like McLeodganj, this is a very rare word. You might not hear this combination much. Okay, तो बहुत ज्यादा split होगा, but it will still work because model can process it because subword token are trained to carry meaning. अब meaning कैसे carry करता है? Because with transformer, right, we have a transformer, what you say, multi-head attention, correct? When you have multi-head attention mechanism in transformer, it is able to remember which word comes after or before and remember it in a context, right? Okay, so I will go back now. ओके, तो ठीक है, आपने इसको टोकनाइज कर दिया, ठीक है। अब नेक्स्ट चीज है मॉडल डेवलपमेंट, आर्किटेक्चर, राइट? तो जो अभी हमने डिस्कस किया कि वी आर गोइंग गोइंग बाय डिकोडर ओनली ट्रांसफॉर्मर डिकोडर बेस्ड मॉडल, ओके। एंड देन लास्ट चैप्टर में हमने जो ये पढ़ा था, राइट, कि you do the embedding, you encode the position, you have the transformer block, and then you have a prediction head, which is your output. Correct. So, ठीक है. So we just discussed about the text embedding. We can do text embedding. Here they have discussed positional encoding a bit detail, right? So positional encoding is about simply like telling what comes when. Okay. So there are three types of positional encoding. One is absolute positional encoding. ठीक है. Absolute positional encoding, you can just say that कि अगर आप दिल्ली को milestone मान लो, so Delhi to Varanasi is like 600, Delhi to Patna is like 900, Delhi to Kolkata is like 1000 kilometer. You have put a kind of origin. From origin, you are measuring each and every distance, and which is absolute distance. There is no relative distance at all. ठीक है. अब प्रॉब्लम क्या होती है एब्सोल्यूट पोजिशनल इनकोडिंग में, कि मान लीजिए आपका ट्रेनिंग डेटा था, ट्रेनिंग डेटा इज लाइक आई आई एम अ बॉय, फॉरवर्ड, राइट? तो इट लर्न अबाउट द फोर पोजीशन, ओके। बट आपको जब डिकोड करना है, मतलब आपने तो केवल फोर पोजीशन के बारे में लर्न किया, यू नेवर लर्न अबाउट द फिफ्थ पोजीशन, करेक्ट? तो आपका जो टोकन साइज है, मैक्सिमम टोकन साइज है, जैसे इट्स अ 512 टोकन, it will be never able to generate 513 token because it never learned about its position, because we did a absolute positional encoding. ठीक है। तो इसमें बेसिकली क्या कहते हैं कि आपने पोजीशन को इनकोड किया और टेक्स्ट एम्बेडिंग दोनों वेक्टर्स को सम कर देता है विद अ वेट, ठीक है। आई एम नॉट गेटिंग इनटू मैथमेटिक्स हियर फॉर सेक ऑफ टाइम, बट हाँ, दिस सिंपली एडिंग द पोजीशन। तो लाइक आई मेंशन, अगर आपके पास पोजीशन ही नहीं है आपके पास डिकोड करते समय अब नए टोकन का, बिकॉज मॉडल वाज नेवर ट्रेन्ड ऑन अ एक्स्ट्रा पोजीशन, तो इट विल नेवर स्केल well. Okay, so this approach captures only information about absolute position, limiting the model's ability to capture relative distance between the token and generalize the sequence with different length and unseen token position, like I mentioned. Now, to इस problem को solve करने के लिए, we came with relative positional encoding. कि rather than encoding the absolute position, right, we are going to encode the relative position. कि rather than saying कि a word position 1, position 2, position 3, position 4, position 5 पे है, we are going to say this word is +1 from this word and +2 from this word. So you did a relative encoding. तो इससे क्या होता है कि आपका जो ए प्रॉब्लम था कि फिक्स टोकन लेंथ वाला, अनसीन टोकन पोजीशन वाला, ठीक है, वो प्रॉब्लम आपकी सॉल्व हो जाती है, ठीक है। ओके, इसकी प्रॉब्लम है कि मैथमेटिकल कॉम्प्लेक्सिटी, इट्स लाइक बिकम्स मैथमेटिकली वेरी चैलेंजिंग टू इम्प्लीमेंट इफ यू आर यूजिंग समथिंग कॉल्ड like linear attention. This is more related to attention block, multi-head attention block. So if you go with this encoding, your attention block will not scale well. Okay. Uh, okay. Then we come to the third, which is currently being used, right? Rotary positional encoding, ROPE, right? This is kind of version of this is currently being used across different like ChatGPT or something like ChatGPT, Llama and all. ठीक है तो इसमें आप क्या कर रहे हो कि आप एक तरीके से आपने मान लो कि आप दो चीज अगर आप देखिए वेक्टर लेंथ है राइट ओके एन एंगल है ठीक है तो दिस इज करेंटली इन द एक्स एंड वाई डिसाइडेड पॉजिटिव फर्स्ट क्वाड्रेंट ठीक है तो यू हैव अ पोजीशन एंड यू आल्सो हैव अ रिलेटिव ओके रिलेटिव sorry you have a position is this okay and relative you are in the first quadrant ठीक है बट इस इमेज में ठीक है डिस्टेंस still it's a relative but you are into position change here correct you are into the second quadrant now ठीक है so basically you are doing a both you are capturing both positional information and you are also capturing the absolute information here in this algorithm ओके तो ठीक है तो इसका अप्रोच क्या है कि इट्स इनकोड पोजीशनल इंफॉर्मेशन इन अ वे दैट रिमेन कंसिस्टेंट इवन व्हेन पोजीशन ऑफ टोकन शिफ्ट ठीक है second is relative position representation so this enables the model to inherently understand the relative distance between the tokens ठीक है तो जो हमारा पहला था फिक्स पोजिशनल इनकोडिंग उसमें क्या होता है ट्रेडिशनल सेंसोरियल इनकोडिंग इज नथिंग बट योर एब्सोल्यूट पोजिशनल इनकोडिंग तो वहां पे आप रिलेटिव नहीं कैप्चर कर रहे थे तो दिस हेल्प यू विद दैट एंड देन जनरलाइज टू अनसीन पोजीशंस बिकॉज इट्स वर्किंग बिकॉज डूइंग रिलेटिव एज वेल ओके कॉन्स क्या है कि मैथमेटिकली इट्स अ वेरी यू नो कॉम्प्लेक्स so okay, now we are done with the two part embedding and positional encoding. Okay, now comes training part, right? So training consists of the three part. Okay, pre-training, SFT, supervised fine tuning, RLHF, reinforcement learning with human feedback. Okay. सो प्री ट्रेनिंग क्या है प्री ट्रेनिंग सिंपली कि बहुत बड़ा डेटा डंप था आपके पास ठीक है डेटा डंप इज नथिंग बट वेब क्रॉल राइट जैसे आई थिंक आई फॉरगॉट द नेम या कहीं पे तो मेंशन even before this there's something else. Common crawl right okay so common crawl is like daily web पे एक crawl run करता है crawls the data and save it somewhere okay so it's so but problem with this is it's not very quality is not great okay c4 is a clean version on top of common crawl okay then github has a lot of data it has a code right if you want to train your model to generate code you need a lot of codes as well okay फिर wikipedia ठीक है books obviously Wikipedia is one of the best quality data set books and archive and static set so these have these four you can say they have rather high quality data in general okay so most of the LLM right all the LLM are trained on these kind of data okay only concern on the training right from an ethical and governance point of view when we work in, from an organization perspective right कि even though you are using common crawl or books these right a good some quality content might have you can say ip restriction right but when you use common crawl it doesn't care about that whether it's like ip or not correct so you might run into legal trouble if you later the point of time that's why if you see right chat gpt or any of the big llm developer they have never disclosed what's their source of data correct because they don't want if they just say disclose right what's the data they have trained on correct then people newspaper will start saying just say a newspaper article is the ip of a newspaper right you cannot train on it correct directly or just say magazine or anything similar right but that's why none of them publicly disclose the training data people are using to build the model. ठीक है. So okay. So if you see right, this example is for Llama 1. So Llama 1 has 67% data from common crawl. C4 is 15%. Database 4.5%. Right? So along that line. Okay. I will move forward. So yeah, this is a basic training, right? You taught the model how to understand the language. Now supervised fine tuning. Supervised fine tuning is nothing but training it on a quality data, right? And tuning it in a way that it start responding to prompt. आपने अभी जो train किया यहाँ पे, ठीक है, base model, it has just learned to continue the conversation. If you give a sentence, it will continue because उसने language से क्या सीखा है. अभी आपने जो पहला स्टेप बेस मॉडल प्रिपेयर किया, बेस मॉडल में ही व्हाट इट लर्न वाज if this word come, what should be the next word? Okay. So if you ask, just if you are directly using the base model after the first step, it is not going to work in a question answer manner. Okay. It will continue the conversation. Whatever you give, it will try to complete it. That's it. Okay. So इसके लिए now we are going to do supervised fine tuning. What you want to build a chat, right? What the requirement here is you give a prompt, it should give you answer. So what you need for the supervised fine tuning, a pair of prompt and response. Correct. So here, so basically our training data, right? Training data is nothing but high quality prompt and response data. So it's we also call demonstration data, right? Because it's demonstrate to the model how to respond to prompt. Okay. So main difference between demonstration data and pre-training data, aside from the format, are the size and quality. Because size is very small, obviously quality is way much better. Okay. So if you see right, these are not very large model, but if you see OpenAI GPTC instruction dataset was only 15,000. If you say they are trained on the terabyte of the data, but just to fine tune something well, you don't need a kind of millions of record. All right, more the better. But what you're saying, if you have a build a good base model, if you can fine tune using a very small set of example. Obviously, even gathering 15,000 is not a small thing because you need experts in each domain, right? If you're it's related to coding or something like that, you need to hire expert to write those prompts to ensure it's accurate. Because any just even you have a 2% wrong example here, it will affect the quality of your model. Okay. So okay, quality like it's very it has to be good. And that they take over 1/3 of OpenAI labelers for GPT demonstration dataset held a master degree. Okay. So, yep, let's move on to the next page. Now, what's the ML objective and loss function, right? Okay. So, ML objective is again your next token prediction. Okay. You want to predict the next token here, and trust your loss function is trust entropy loss function. Basically, what you want to minimize. Okay. Okay. So, okay. So just say you did the training, right? Once after doing the training, supervisor it usually generate a grammatically correct and reasonable response. Okay. However, it might not always generate the best response. Okay. Its answer can be unhelpful or even unsafe, right? Let's say if you ask a question like, what are the some effective way to reduce my stress? You can say go skydiving for adrenaline rush. Okay. Or shame on you, try meditation. Okay. So so in step one, you taught the language. In supervised fine tuning, you taught how to do the conversation. But conversation is still not tuned for the human preference, right? That's where the step three comes into picture. What we call reinforcement learning with human feedback. So I not I think most of you might have heard at least reinforcement learning, right? Reinforcement learning, you can see it's like teaching a child, right? Okay, with a reward and a punishment, right? Okay, uh, if you do well, you'll get a prize. If you don't do well, you'll get punished, right? Okay, so you reinforce the learning. Okay, what is the right step to take after this step if to get the reward? Basically, model's incentive here is the reward, that if I do well, I will get rewarded. Okay. So now we are into RLHF. So now this is the alignment stage, right? It adapts the model to generate responses preferred by the human. Okay. So in SFT, model learns from demonstration data to produce a class-wise response to a given prompt. Okay. So however, demonstration data provide the model with one class-wise response for a prompt. Okay, which is not necessarily most helpful or relevant response. Okay, so in SFT, supervised fine tuning, for each prompt, we give one response, right? It might not be the best one also. Okay, using multiple responses can be plausible and some will be more relevant than others. Okay, okay. So idea behind RLHF is like you do two-step process. First thing, you train a reward model. First thing, you need to have a reward model which is good enough to tell, okay, reward, this is the score, this is the response, right? Then using the reward model, you optimize the supervised fine-tune model. Okay, so training a reward model. Okay, so you have a prompt, you have a response, you give the reward model and a score of 1 to 5, it give 5. Okay, so your model will learn, okay, this is getting the highest score. Next time when I get if I answer a query, I should keep in mind this, what the answer can get me the highest score. Okay. So the example we were discussing, right? What are the some effective way to reduce my stress? Exercise regularly and maintain a healthy diet. So you gave a score of 5. But if you give a response, shame on you, try meditation. The reward model gave a score of 1. Okay. How do we build a reward model now, right? That part. Okay. So you can use another transformer model as a reward model in general, just a smaller transformer model, because now there are lots of available. Just say, but you are doing it for the first time, right? What you can do is you can use your supervised fine-tune model itself as a reward model. Just you need to add a prediction here. Okay, because you already have a supervised fine-tune model, you just need to tell it that, hey, if this is the answer, instead of generating a text response, generate a numeric response, like a graded response, A, B, C, or 1 to 5, or something like that. Okay. Okay. Now creating the preference pair. This is nothing but you have a prompt, you have the multiple responses. Okay, this is a training data. We are constructing. First, you decided what the reward model you are going to use, right? Okay, so you are saying that you can use any existing AI model, or you can use your previous supervised fine-tune model itself. Now, to train that reward model, you need preference pair. If you have a question, these are the responses, right? And you are ranking the responses. Yes, ma'am. Go ahead.
So that sentence that you can use a copy of the same model is actually wrong. Nobody uses it. It's frowned upon because you don't. This is like you're making something out of something wrong already. So you're trying to improve your model. You'll not use the same model. You'll not make a copy. You'll use some other model that has already been proofed, tested.
Right, ma'am. But just say GPT was building model for the first time. There was no other model available. What
Yeah,
would
so
you
then at that point, they would use a previous generation LSTM kind of model that can become a reward model.
right, ma'am. So, but LSTM has a limitation, right, ma'am? It doesn't scale well. So I'm just, yeah, it's just one of the options. We can go with something which works for us, right? Yeah.
Yeah, yeah, yeah.
Okay. So prompt is so you have a response ranking, right? So you ranked, right? Because See, why ranking, right? A simple question is that. So it's like you wrote an exam, you give a exam for, it's just exam में हम ऐसे लिखते थे ना, तो ऐसे कितना भी अच्छा हो, कोई टीचर मतलब 10 में 5 देगा, कोई 10 में 7 देगा, कोई 10 में 9 देगा. It becomes very subjective, right? Depending upon the evaluator. So rather than, giving the score, you are giving the ranking. Ranking सब बता पाएंगे this essay is better than this, but if you give them a definite score, it becomes subjective. So that's why instead of going with the absolute score, we are going with the ranking. तो हमने प्रेफरेंस पेयर क्रिएट कर दिया. ठीक है. अब हमारा गोल क्या है? गोल है जो आपका लॉस फंक्शन है, आप अपना जो वर्स्ट रिस्पॉन्स है उसका जो स्कोर है और जो बेस्ट रिस्पॉन्स है उसके स्कोर का डिफरेंस जो है आपको मैक्सिमाइज करना है. ठीक है. आप मैक्सिमाइज करने का मतलब यू वांट टू मेक एस विन मोर एंड एस लूज लोअर. करेक्ट. तभी तो मैक्सिमाइज होगा. देन यू आर ऑल्सो क्रिएटिंग अ गार्ड रेल. दिस शुड बी द मिनिमम मार्जिन, राइट? कि इतना डिफरेंस तो होना ही चाहिए टू का. क्योंकि मान लीजिए आपका रिस्पॉन्स जो है 0.5 या 0.1 था. ठीक है. दैट्स अ बैड. जैसे 1 और 2 था. 1 और 2 बोथ आर नॉट अ गुड स्कोर, राइट? करेक्ट. So you don't want to learn, you don't want model to learn from that. You are saying that M is my margin and this should be my response difference should be more than margin. Otherwise, if it's a negative or something, give it a 0. You are not going to learn from it at all. Okay. So goal of this reward model is to maximize this last function. Okay. Okay. Now we are done with reward model. So reward model का फायदा क्या हुआ? You have a score when you give a prompt and response. ठीक है. Again, just to recall what we are doing, we are working on the last step, reinforcement learning with human feedback. Okay, so last step is there. So first, what we needed was the reward model. Now we have a reward model. Correct. We are going to optimize the SFT, the step 2 का model using the reward model. ठीक है. तो इसमें आप क्या करोगे? दिस इज वेरी सिंपल, राइट? आपने मॉडल रिस्पॉन्स जनरेट किया, आपने रिवॉर्ड उसका देखा. ठीक है. फिर आपने क्या किया? इफ योर रिस्पॉन्स इज गुड, यू विल अपडेट द मॉडल वेट, और बैड अकॉर्डिंगली यू आर अपडेटिंग द बेसिकली मॉडल वेट. ओके. यू आर ट्रेनिंग RL एल्गोरिथम अपडेट द मॉडल वेट टू मैक्सिमाइज द एक्सपेक्टेड रिवॉर्ड. तो जो आपका LM मॉडल है, तो LM मॉडल का वेट अपडेट हो रहा है सो दैट you get the maximum score. Okay. Okay. So yeah. So yeah. So this image explains it well. So what we did, right? We had a pre-training जहाँ पे हमारे पास इंटरनेट डेटा था. ठीक है. तो हमारे पास यहाँ से बेस मॉडल आ गया. ठीक है. Here it was no token prediction. Then you went to supervised fine tuning, what we call SFT. You had the demonstration data, high quality. Then again, you got a supervised fine-tune model. From supervised fine-tune model, you built a reward model. It can be separate or something you built using like another model. Okay, so you have the reward model, and then you did the reinforcement learning with human feedback, and you got the final model. Yeah, ChatGPT or Gemini. Okay, now comes the sampling. Okay, this was covered in very brief in last chapter where we discussed about the beam set. But यहाँ पे थोड़ा और डिटेल में, sampling is nothing but how do you select the best token, right? So if you are aware, what ChatGPT does is it generates the probability. Okay, what's the most probable next token? Okay, so there can be multiple token. करेक्ट. जैसे आपने एक सेंटेंस जैसे कैपिटल ऑफ फ्रांस इज पेरिस शुड बी 95% probability. Some junk can be 5% probability, right? So it will select the Paris. How this Paris selection works, right, is what being explained here. Sampling. Okay. There are two types of methods. One is deterministic, another is stochastic. ठीक है. So deterministic में greedy search आता है, beam search आता है. Stochastic, which is if you use if anyone has used OpenAI or any Hugging Face APIs, right, you'll find this parameter top K. which you can define. So basically, current set of algorithms use this top P, this sampling, stochastic and top P. Okay, so we are going into detail of deterministic, right? Deterministic is very simple. ठीक है, आपका मान लीजिए पहला वर्ड था जो इन्होंने इमेज दिया हाउ, ठीक है, इसके बाद तीन वर्ड प्रोबेबल है, ठीक है, हाउ कम, हाउ आर, हाउ डू। पहले की प्रोबेबिलिटी 14%, 56%, 26%, ओवरऑल 100% है। तो जो मोस्ट प्रोबेबल वर्ड है ग्रीडी सर्च, राइट, what's the best at this step? So you go with next best. After R, what's the next best possible? U. Then next best possible doing. This is simple selection based on the probability. Okay. अब इसका प्रॉब्लम क्या है, ठीक है, इट कैन लीड इनटू रिपीटेशन, राइट, क्योंकि ऑल इट इज लुकिंग फॉर द नेक्स्ट प्रोबेबल बेस्ट वर्ड, ठीक है। इससे क्या हो सकता है कि कई बार इट कैन गेट स्टक इन अ लूप एंड इट विल स्टार्ट जनरेटिंग सेम थिंग अगेन एंड अगेन एंड अगेन। ओके, सेकेंड थिंग इज सब ऑप्टिमल जनरेशन, ठीक है। तो ग्रीडी सर्च इग्नोर्स अल्टरनेटिव पाथ, राइट। सी, तो हो सकता है कि हाउ के बाद हमने आर लिया, बट आर के बाद का पाथ अच्छा नहीं था, बट बिकॉज ऑफ ग्रीडी सर्च यू हैव टू गो विथ ओनली दिस वे। हो सकता था यहाँ पे इवन तो डू इज द सेकेंड बेस्ट, बट डू के सेकेंड बेस्ट के बाद नेक्स्ट sequence of word were our response that you would have got would have been much better, right? Okay, to solve this problem we go with beam search. Okay, beam search is, it will generate multiple answers. Okay, how come, animal, how are you, how do you. So आपने multiple response generate किया each step. Okay, and you are not kind of, you are not limiting yourself to one. Okay, you are limiting, you are going to go with multiple answers, and at the end you will select the best one. So what we say top k, right, it is going to go with top k sequence where k is configurable. Okay, main problem with beam search is inefficiency, right? It's because it's multiple sequence generate kar raha hai, ठीक है, and you know that decoding is a sequential process, one of the main bottleneck of transformer model, right? Encoding happens in parallel, but decoding happens in sequence, right? That's one of the also reason for the high cost of LLM, because you are not able to implement parallel calculation computers. So ठीक है, inefficiency and reputation, ठीक है, again it has a problem of getting repetitive and generic responses because it's going with probability, most probable one, ठीक है। तो you are saying, okay, you don't want to go with deterministic because it has inefficient or it can get stuck in loop. So you go with random method, what you call stochastic method, right? ठीक है, तो multinomial sampling, right? Okay, multinomial sampling is simple as आप जैसे कि आपका bag of words है, right? कि आप लॉटरी सिस्टम आप मान लो कि आपने एक बैग में ढेर सारा रिवॉर्ड डाला है, आपने हाथ डाला और एक वर्ड निकाला, ठीक है। अब मान लीजिए एक टाइप का रिवॉर्ड, जैसे टेडी बियर सबसे ज्यादा था फ्रीक्वेंसी में, तो टेडी बियर की यानी कि फ्रीक्वेंसी ज्यादा है, बट आईफोन मान लीजिए कि पूरे बैग में केवल एक आईफोन था, तो आपको आईफोन पाने का प्रोबेबिलिटी कम है, राइट? So this is simple sampling. More depending upon how probable a word is, more likely it is going to get selected. But if there is also chance that a non-frequent word can also get selected. 5 or top 10 words. Okay. अब इसकी प्रॉब्लम क्या है, ठीक है। इसकी प्रॉब्लम आई विल एक्सप्लेन इन मोमेंट। तो इसकी प्रॉब्लम ये है कि हो सकता है यू आर सेइंग, यू आर सेलेक्टिंग, सॉरी, यू आर सेलेक्टिंग द टॉप 10 और टॉप 3, बट हो सकता है कि पहले वर्ड की प्रोबेबिलिटी 99% हो, बाकी वर्ड 0.001, 0.001 ऐसे ऐसे हैं, still there is a chance they will get sampled because how you are selecting the word, करेक्ट। तो इस प्रॉब्लम को सॉल्व करने के लिए यू गो विद टॉप पी सैम्पल, ठीक है। पी मतलब प्रोबेबिलिटी, ठीक है। यू आर सेइंग यू आर गोइंग टू सेलेक्ट टॉप as many word which for which probability sum up to 90% or 80%, right? So just say now here what happens, right? कि आप सर आई विल गो टू टॉप पीरियड या तो आपने one है, या तो टॉप पी में देखिए आपने मोड़ा पीक सेट किया 88% पे तो पहला वर्ड ही 89% था तो यू आर गोइंग टू सेलेक्ट ओनली वन वर्ड ठीक है बट से आर इज डूइंग लाइक आर इज डू कम makes up 88% right so you will get one of them and they might be relevant but in this case right only lot is relevant so you are going to get only this so top p solves the problem from the previous algo top k कि आप irrelevant word selection नहीं करोगे यहाँ ठीक है Okay, so Toppy and Toppy. Okay, you will hear a lot about temperature, right? Okay, अगर temperature is kind of uh, एक knob or whatever is right. You can turn it on to make it GPT more creative. You can turn it off, set it to zero to make GPT deterministic, right? तो टेम्परेचर जैसे आप रैग बिल्ड कर रहे हो जैसे आप जैसे यू आर बिल्डिंग अ टेक्स्ट टू सीक्वल बेस्ड रैग ओके कि आपने अगर एक ह्यूमन लैंग्वेज दिया एंड यू वांटेड टू जनरेट अ सीक्वल you don't want GPT to be creative there. Okay. You want GPT to give you exact sequel, right? From your RAG database using the like what you call it, embedding algorithm like ADA or something. So you set temperature very low, 0.1, 0.2 or something like that. तो आपने जब लो टेम्परेचर सेट किया तो आप P का जो वैल्यू है वो भी आप लो सेट कर मे बी आई विल एक्सप्लेन इन नेक्स्ट सो बेसिकली टेम्परेचर इज अ पैरामीटर व्हिच वी सेट राइट तो इससे क्या होता है कि टी जितना कम होगा टेम्परेचर मॉडल आउटपुट बिकम मोर डिटरमिनिस्टिक ठीक है और लो अगर हाई होगा ठीक है तो टेम्परेचर ऑफ जीरो कंसिस्टेंटली लीड टू सेम आउटपुट राइट सैम्पलिंग डिटरमिनिस्टिक so usually जैसे whenever I build RAG, I go with 0.05 or 0.1 or 0.2. Max I have gone to, in my experiment is 0.2 and text is equal. Just even code generation, right? For the code generation, you don't want to go with a high temperature and P also. Okay. Okay. So, okay. So this explain this image explains it very well, right? कि आपका टेम्परेचर वैल्यू आपका जीरो आपने बहुत लो टेम्परेचर किया है तो आपका प्रोबेबिलिटी डिस्ट्रीब्यूशन कैसा दिखेगा ओनली वन वर्ड गेटिंग सेलेक्टेड आपने टेम्परेचर 0.5 सेट किया आपका जो सैम्पलिंग डिस्ट्रीब्यूशन है कैसे चेंज हो रहा है ज्यादा सेट किया और ज्यादा सेट किया आपके पास और ज्यादा काइंड ऑफ प्रोबेबल वर्ड आते जा रहे हैं सैंपल में ठीक है so typical temperature value, permissible value for GPT is if zero between 0 and 2, ठीक है तो while तो एक guideline है GPT का right higher value like 0.8 will make output more random while lower value like 0.2 will make more focused. So this is one of the very famous interview question also अगर आप कभी AI engineer रोल के लिए तो what's the temperature and in which use case 10% threshold. Okay. Creative writing, we are going to 10% threshold. Okay. Creative writing, we are going to set more very creative, like more P and temperature. You because you want larger corpus of text. Chatbot response, you want it to be neither too creative, neither too deterministic. You are going with a middle ground. Then something called repetition penalty, where you check that if their words are getting repeated again and again, are getting into loop. So there's a parameter called no repeat engram size and hugging face. I won't use, but yeah. So you can use it to penalize or interrupt the response if it goes into repetition. Okay, so I am. We are almost near the time and evaluation. I think we all know that like there are multiple benchmark like truthful QA, math QA, like right. So you use those trivia QA and Q. So these are publicly available benchmark on which you can test your build model. Okay, so I'm not getting into this today. Uh, so online evaluation. And then overall, so yeah, so whatever we are discussing till now was the training pipeline, right? After training pipeline, you also need to build an inference pipeline, correct? So हमने model to build कर लिया, but if you know one of the requirement we discussed was that to have safety checks in place, right? तो आपने टेक्स्ट प्रॉम्प्ट किया, उसको सेफ्टी के लिए फिल्टर किया, आपने पीआईआई के लिए चेक किया सेफ है या नहीं है, ठीक है? उसके बाद प्रॉम्प्ट इनहैंसर लाइक यू कैन यूजर की क्वेरी बहुत क्लियर नहीं है तो यू यूज अनदर एआई टू मेक क्वेरी मोर क्लियर, ओके? तो उसके बाद यहाँ पर रिजेक्शन, उसके बाद अगर सेफ नहीं है तो आपने रिजेक्ट कर दिया, ठीक है? या प्रॉम्प्ट इनहांस करने के बाद आपने रिस्पॉन्स जनरेटर, विच बेसिकली दिस इज योर मॉडल, राइट? द मॉडल यू बिल्ड हियर, एग्जैक्टली दिस इज वेयर आवर ट्रेनिंग पार्ट कम्स इनटू पिक्चर, ठीक है? फिर उसके बाद आपने फिर रिस्पॉन्स की सेफ्टी इवैल्यूएट की, सेफ है या नहीं है, अगर सेफ है तो आपने वापस उसको एज अ रिस्पॉन्स दे दिया. So this is inference pipeline. I know I covered in very short, but in yourself and yeah, pretty much it. So next
Yes,
chapter will
yes, Ankur. So,
we have Mina, if anyone wants to add in more. Manu sir, any last words? Sir?
Ankur, I just want to ask one thing, Abhishek. We have seen a lot of calculation in the formulas to calculate the temperature, or initially in the
Why is
model
it
also.
breaking for me, Abhishek sir?
Can you hear me?
I don't know if only breaking for me or if for everyone.
Can you hear me properly?
I
No.
can hear you.
yeah, I can hear too.
Yeah.
Okay.
I will ask you one to one. That's okay.
Oh no no. So yeah, Abhishek, go ahead. I just removed my AirPods. Yeah. Please.
I was asking that in the interview setting, there is a lot of calculations we did to calculate initially the model data and also the temperature. So do we need to do it in the interview setting, or we assume that we will select a model which has a low temperature as high as 0.2?
No, sir, it's not. You don't select a model with low temperature. You set those parameters.
You
It's a
set those
parameter.
parameters.
Yeah.
Okay, okay, okay.
Ankur, I have one more
Thank you.
question on the temperature thing. I have a question. Like my company has exposed these chatbots on our internet site, and I was also they also include this temperature parameter to set it. We can set it our own if we want to recreate this any chatbot. And I just noticed like for our the chatbot that helps to developer, that temperature value is high, like 0.5, and for the other chatbot that just a response to like a general query for the I value HR policy or like that, they have put as 0.35. So this not looks good. Like you say, like for the coding related task, the temperature should be low.
But sir, another perspective for HR policies, right? You can don't want to answer wrong question, long answer. Say, if I ask about, hey, how many leaves I can take, and model becomes creative, right? Okay. If you get sick, you can take as many leaves as you want. Correct. Okay. You don't want model to become creative with policies. Probably, I think that's the one of the reason they might have set it to low.
I see. Okay.
Okay. All right. Anything else?
Thanks for the good session.
Thank you, Ankur.
Yeah, great job, Ankur. This was a very good session.
Yeah. Thank you, ma'am. So yeah, over to Radha sir now. Next
Thanks,
session.
Ankur.
Thanks everyone. Yeah. Have a good day. Bye bye.